So good morning. I'm Vijay Jethani. I'm Cloud Solution Architect at Microsoft. So for today's session on machine learning, we will see what exactly the machine learning is all about. So we will look at the specific components which make up the machine learning, and we will understand why we actually doing machine learning or what are the use cases where machine learning will help out. Okay. Similarly, what is the role of DevOps if we really want to apply a DevOps methodology on machine learning? So that is what we will cover in why DevOps for machine learning. And then while we know that DevOps is important for machine learning, how actually DevOps automate that machine learning process is what we will look into. And finally, we will cover up the native tools because at the end of the day, while you are implementing everything in cloud, so cloud should provide you out of box tool to help you implement that, irrespective of whether you are a coder or whether you are a data scientist or you are working in an infra or any particular platform services. Okay, so that is the agenda for today for DevOps for machine learning. And while you move out of this session, you should get why we actually doing the machine learning and then look at the tools and obviously the DevOps methodology, how we are implementing that and getting ready for your implementation. So while you have gone through this session, you should be able to set up the base prerequisites for your implementation. So upcoming will be our hands-on lab, where we will cover deep dive into more of a technology implementation. What are the tools you are being using through? So we will get hands-on to each and every tools you can say, or the from the UI per se, how you work with those designer or workflows. Okay, so that is what we will cover in our hands-on lab for ML, which is next week from 1:30 p.m. to 5:30 p.m. on 22nd of March. Okay. So let's get started with our first topic on ML concepts. So while we are doing ML, it is important to understand where exactly the business use cases or the respective what are we trying to achieve out of it, where that exactly fits in. So if you see broadly where you will apply analytics, it fits into all of these four categories. Now, if I have to give you the example of what we have been doing in our traditional day-to-day work, we work with a number of technologies or applications, I would say. All of them produce some kind of logs. Okay, so here if I have to correlate with the cloud technology, we can consider example of log analytics or log workspace which we create. Okay, so while we get those logs, what kind of information they give is called the descriptive analytics. That means something happened, any event happened, it just informed me and I got to know that this is what this particular service is up and running, started, stop, whatever you can think of. Similarly, going further, if we want to really troubleshoot if something is going wrong with an application, what kind of the diagnostic I want to run on the top of that. It can be from the logging, or if I have to run any particular tool to fetch like kind of a network trace or network watcher you might be using, something similar on that ground. I need to do some digging of what is going wrong, why service is not running. To find out, I do the diagnostic analytics on top of that. Okay, so this is what where our traditional while you do work on your platform as a service, infra as a service, or any of the software as a service, we do this quite often to keep our machines or our environment up and running. However, for us to go further, that means predict, we need some technology which understands this kind of data, that, or I would say an analogy, an intelligence on similar to human, which can tell us going down the line this is going to happen. Okay, so that is where we say predictive analytics. Okay, so what will happen is what we are predicting over the time, that this will surely happen given this particular data or the flow since 1 year down the line, or from our past experience on that particular workload. Okay, so that is what we say, that we can predict based upon what kind of information we have at the hand and the metrics we have at our hand. Now, other type of analytics which is based on this is a prescriptive. That means how actually we make it happen. Like something, the example which I can correlate here is your robotics or a self-driving car. They both have to learn what is in front of them and adjust accordingly. That they have to adjust their route accordingly to reach particular destination. So that is where they have to take corrective action. That means first they have want to learn from what they are or which stage they are, and accordingly take the corrective action to make it happen. Or if it is your industrial equipments, they of the robot will go and actually pull that particular whatever the workload or the device and put it at respective location. Similarly, if it is a self-driving car, it should know where the signals are and where there's a crossings and all those things. So those all things are very important for us to prescribe to or make it happen with the help of prediction. Okay, so if you correlate these predictive analytics and prescriptive analytics, this is where your machine learning will sit in. Okay, so ideally descriptive and diagnostic. For this, our dashboards are sufficient enough to give you those analytic information in form of any graphs or something that this happened. You can always go to the historical information, but that does not require your machine learning. That means does not need to train that, because that information is available to us, and with the help of a little queries, we can actually get that working. Okay, so that is what we have to look in from the descriptive analytics and diagnostic analytics. However, for machine learning, it has to be very specific on prediction and prescriptive analytics. Okay, so this was a broad overview of analytics and where your use case will fit in all of these four categories. Okay, now moving further, we hear a lot about machine learning versus deep learning. So what are they? From an AI perspective, something which copies or mimic human intelligence is artificial intelligence or AI. Now, this is just a broad term, right? So this can be anything from doing a simple task of prediction or something at a particular time. You are predicting weather, you are predicting the sale, you are predicting some IoT device going wrong at a particular point of time. So we are applying the machine learning concept. So that is where you have a specific task or you have a model at hand, or I would say model in a simple terms. If a layman terms, I'm just calling it a program which understands the data it has at the hand and able to predict what's going to go wrong or what we have to take corrective action for. So that is the machine learning. Okay, now deep learning is a specific use case of machine learning where if you have seen for the prescriptive analytics which we talked about, it corrects itself, like case of robotic arms or robotic technology. Similarly is a self-driving car, or similarly is something which you are automating. Okay, so these are the technologies or the use cases where you will require deep learning. Okay, so ideally AI is the broader term. Under AI fits the machine learning, and a subset of that is a deep learning, depending upon what kind of use case you are working on. Is it a robotics or it is a self-learning model? Then yes, deep learning is required. If not, we call it as a traditional machine learning, where we are just doing some kind of prediction based on the data we at our hand. Okay, so these are some terms you will come across the machine learning. Now, there are also the naming conventions given to them based upon what kind of the algorithms we use, right? So if I have to say supervised learning, it's something that we are very well aware of and we know what kind of data we are expecting, okay, or what kind of the parameter or metrics we are monitoring. Okay, so that we call the supervised learning. That means we already know for what we are. like say for example, for any particular medical diagnostic, you know what kind of parameters you are looking for. So that is called a supervised learning if you want to apply the AI on top of the data for n number of those particular tests being conducted. Okay, similar is the like something sales, like sales consumption over the time period. You already know that this is for what purpose it is being used. Unsupervised learning is like we do have data, but we ourselves don't know where they would or what particular data points will come together, or I would say classifying them or clubbing them together or calling them a similar. So that is where we call unsupervised learning, where we do have the data but not sure about where the correlation or to what extent they are similar or dissimilar. Okay, so there is where you will have unsupervised learning, where we are really trying to find out what is the best fit for them. We don't have model at our hand. Reinforcement learning again correlates with your deep learning. That means it learns from what we have known so far. Okay, and try to prescribe, try to make it happen based on no prediction. So that is called the reinforcement learning. So these are the three techniques which the or the naming conventions you will hear quite often from the machine learning. Now, everything in machine learning is a program, right? It we give some input to it, we get some output based on some algorithm or programs. So these are some common algorithms you will come across, like binary classification is nothing but saying yes or no, or whether that happened or not, or probability of getting that done, yes or no. Okay. Similar is a multi-nominal classification, but here in spite of just having the binary or the only two data points, it has a multiple data points. Like I would say a sales consumption over a period of time on respective months or years, so on. So that also you can classify. Anomaly detection, moreover, you will face where, like say suppose I am doing some maintenance on some IoT devices, right? So I want to make sure that when that particular device will require maintenance or it is not performing up to the required capacity or the desired, it is not providing the desired output. So that is where you have to detect the odd man out kind of thing from that to make sure that yes, this device will require service now. Okay. Similarly, going for the regression, it is exactly the same thing, but we reiterate ourselves, right, to find out from the complete data set that where that particular data fits in, or where are those data points aligned towards which particular uh, respective output. Okay, so that is where we are trying to find from the regression. Now, going further on time series, it's more on the seasonality or the that particular time bound, like say suppose sales consumption for year 1 versus year 2, what was the changes or difference to that. So you want to compare those things, and if you have any prediction of 30% increment to those, that is where you can make out. So these are some business use cases which you have to brainstorm while we think about the machine learning algorithms. Okay, and similarly, if you have to group similar kind of people or similar kind of the animals, I would say, or a similar kind of n number of use, the examples you can take from whether similar kind of people, geography, then as I said, the species, animals or whatever you can want to classify it based on image classification or something of that sort. You can actually cluster them in a respective that from the image or emotion detection and all those things also comes into this clustering or grouping of the similar objects. Okay, whether they are smiling, crying, and all those things. So this is kind of a brainstorming of what we are expecting out of machine learning and how we will make it happen. That we have some idea, we want to have a data to it so that it provides an respected output for us to predict where it lies or for what it is. Okay, so based on whether you are doing supervised, unsupervised, or reinforcement learning, the technique will be different. Now, for us who may be starting new or we are started, we have some intermediate knowledge about machine learning. There is also called the cheat sheet, which you can choose based upon the parameter you expect or the use case which you are working on. So how to select machine learning algorithm, and this is readily available on our public website for machine learning. Okay, so you can check about what specific you want from the data. Okay, and select based upon the first of all what kind of the category you're working on. So that is the text analytics, regression, clustering, anomaly detection. So whatever the algorithms I have talked through, so it gives you overall algorithms which are available out of box. Similarly, if you want to go on the additional metrics of and the accuracy should be 99 and above. Similarly, or I would say 80% and above, 70% and above for respective use cases, or classifying them in a respective groups. Okay, what kind of the deep learning or the time it takes to do that particular work for me. So training time is also important, whether that is linear or non-linear. That means over the time whether it remains constant or it follows a specific equation, a scientific equation. So those all things you have to take care while you actually select those algorithms. But this is kind of a cheat sheet for you depending upon what you want to do. As I said, two things you have to remember. First of all, where you fit your use case. This is important. And then based upon that, what algorithm you select. This is a second selection. Okay. Third selection, this purely depends upon the additional parameters which may be there, which may not be there. That depends upon the customer requirement at that point of time. Okay. So this is a bit smaller. I can enlarge that. Okay, so ideally you can see that how we are deriving that information and what kind of the algorithms they have been named for, and what kind of algorithm fits into regression. Similarly, what kind of algorithm fits into classification, anomaly. So these are some names given. So while you do actual work on that, you will understand more about respective category and then algorithm to select within that category. Okay, so moving back. Now, till the time we were only talking about the concepts of saying this is what is available to you and this is how we will classify. These are the some techniques we have, and finally the algorithm to select for. What about implementation? How do we actually implement them? So for them we have machine learning frameworks. Okay, so PyTorch, TensorFlow, Scikit-learn and Keras are some of those frameworks. Now, when we say frameworks, obviously that framework should give me the tools and libraries to work on, or I would say do end to end for what I need from that particular data or that particular model. Okay, so with that help of that model, the moment I pass the data, it gives me the desired output. Okay, now where it fits in purely depends upon, again coming to the basic technique, whether you want to run supervised, unsupervised or reinforcement, and based upon that it will also classify your deep learning, machine learning, and or I would say a traditional machine learning versus deep learning. So those all things will come to you based upon the use case you select. However, to just classify these algorithms, PyTorch and TensorFlow are more of a deep learning technology, or I would say the pioneer technology. So PyTorch is from Facebook. Similarly, TensorFlow is from Google. So they already have done a lot of work on this and already built the models ready to use or ready to consume, I would say, for the machine learning techniques. However, if we are starting new and we want to really experiment ourselves and to learn or to grow as a scientist or grow as a technician doing the machine learning or AI technologies, then Scikit-learn is the framework you have to choose from, because it has most of the things what you will require to learn from or how to make your own models. Okay, so Scikit-learn is the technology or the framework you have to use for training yourself for machine learning on AI. And if as you mature yourself, then obviously you can customize the other workflows, TensorFlow and PyTorch as well to your own needs, or select the already existing and modify those bits. But for us to start or get experience on this particular machine learning technology, better to start with this Sky scikit-learn and then go ahead to TensorFlow and PyTorch. Okay. Keras again is built on TensorFlow. Okay, so it eases the workflow, or I would say a UI. If you are not from, if you don't have that experience or hard-coded skill for TensorFlow, it helps us implement that in a simple way. So again, this falls under this TensorFlow framework itself. So ideally, what I'm trying to say here is PyTorch, TensorFlow, and scikit-learn are the three frameworks which we will target more for machine learning. Okay, so frameworks, why they are used? It's for implementation. So they will provide us a library to implement those particular machine learning technologies or respective use case. Now, as we understood the libraries and which framework to use, now let's understand what the machine learning will look like, or in our terms for Azure, what the machine learning components we will have. Okay, so first of all, to look at, we have obviously the compute. Depending upon the complexity of the solution you might be working, you may have a single node or you will have a cluster of that node. And as you know, the data may come from any particular semi-structured, structured, or any. So that is where we have the different data and storage connectivity. Okay, and this can also involve your modern data warehouse terminologies, or whatever we learned so far last month with the help of what technology and tools you can use. So you can also think of the data is not in a form which is required by our model. Okay, for machine learning model. In that case, you need to transform that with the appropriate ETL or ELT cycle. So we call extract, transform, and load, or extract, load, and transform. Depends upon purely the use case, what kind of the work you want to do on top of the data to make it presentable. Okay. Similarly, orchestration, right? So what kind of engine you want to run, right? So obviously we have doing a number of tasks. So we will have our models, or for even training models, we know what kind of the data it requires and what kind of application we have to build, make available, which takes a decision on behalf of us. So that is the reason we require this workflow orchestration, which is kind of a chart. uh, Everyone knows the chart, like how we give an input and it does some processing on top of that and gives output. So our workflow will be a kind of a chart which has some input at the start, and at the end it gives us the desired output, but performing a number of steps, also take the decision behalf of the AI, or I would say a human intelligence. Okay, so that is what is required from an ML. Now model registration is management is required once we actually train that and make sure that yes, this particular model is nothing but the end-to-end flow, or what end-to-end steps which we took, right from transforming our data or making it presentable to actually running it through that engine and providing the desired output. So that is called the model. So with that model, we have, once that is ready, we have to register that so that we can reuse that. The way we have been saying that PyTorch and TensorFlow are already pre-built on respective technology or use cases. So we have to make sure that we can register those models and train those models for reusability. If anyone else want to use, say suppose any particular industry, you can talk about health industry, insurance industry, they may have all different use cases or scenarios to go through. Okay, so the requirements will be all different from different industry standards. Okay, so that is what we want to move through. Okay, on the model registration and management. Now, obviously, if it is trained, then obviously we have to check for its accuracy at number of times. So that is where we will come to the metrics and monitoring. What exactly to trace for while we classify them, or how do we measure that this is really running up to its desired parameters or desired metrics, right? So we have to have a monitoring of that. using respective technologies. So that is where we will look into that particular part. Model deployment, as I said, this is again one particular the component we have where we are ready with that, and for us we just directly go and reuse that kind of a select that as an application code, and we don't know what is there. It's kind of a black box for us. So that is where all of these components make up the Azure machine learning for us to deploy for. So these all you will actually see through with the help of different components while we move further. Okay, so I will just pause for a while so that I can show you what exactly we covered from concepts before we move further. So with this concepts in our hand, now we are good to move further on what exactly the technology components on ground make up the machine learning. Okay, so to know why we really require DevOps for machine learning, we need to understand first what is the machine learning requirements. Okay, what are the different components and the data it works through. First of all, we are doing the data and model version control, right? So we are classifying respective use cases or training our models based on the requirements. Okay, so obviously we need the testing frameworks or model. Similarly, as I said, ET and ELT, that transformation that we require. So we call the service and data management part of it. Reusability, once we are ready to be publish that as a service, then obviously we want that to be used for specific industry use case. Okay. Compliance and auditing is a very important security aspect. That means while we are doing this, we have to make sure that we make, like say suppose example is salary of our leaderships, right? So leadership or management or any of the higher authorities. So for any reason, data is being put in the system, so that should not be leaked. Or I would say for even any particular categories, it should not be leaked within your organization or even across the public forums. So that is where while we do the ML, we have to make sure those particular components or the data sets are hashed out so that that is not being provided in a general for the security reason. Similarly, for any of your military or where or I would say the banks where sensitivity of the monetary control is required. So that is where we require the ML should do its job in a proper or I would say prescribed way. Okay, so at times we also will require that like from an high availability perspective on disaster recovery, if we want to make that model or that particular complete end-to-end solution available with no time, so we can require that to be restored. Okay, similar is for making that available. Obviously we want to package that model so that it can be reused in some shape and format. So these are the requirements for a machine learning at a broader. If you work with a machine learning, I think you will understand each and every component how we do end to end. Now, the challenges which we are trying to resolve with the DevOps is, first of all this basic understanding is with our either the data scientists or the operation guys who actually implement this on ground. So for us to be successful on ML, we know both of them to work together. That is the first thing. And second thing, as we have seen n number of components, the complexity is always high, right? So it's highly complex environment for the solution. Even if a smaller mistake will lead to wrong results. So that is where we are saying that we require a skilled resource here, right? And without standard operating procedures, it can be your any automation scripts or done in a respective standard way, we are prone to errors. So that is what we are saying from the any setup, right? Any solution implementation. And as you have seen the different use cases, we also know every use case will require a different component, a different transformation layer for the data. And similarly, obviously, the algorithm will also be different. So the implementation overhead which we had for each of those machine learning techniques is different and complex. Okay, and if we really want to make it like work with cost effective manner, we want to make sure that we are able to deploy them within no time, or I would say a minimum time for us to consume those models, because those are not like a production use cases. This is something to be on at times you require just for that particular time or that particular month or that particular year. So depending upon where you require that, if you don't require by 24/7, then those machines or frameworks should not be running 24/7. So that is the reason force us to use the DevOps methodology so that we can bring that particular framework or solution implemented within no time. Okay. Similarly, the while our data comes from different source, that is again the biggest challenge. The data may be in a consumable format, it may not be in consumable form. So every time to track it, our model is correct or our implementation is too complex even for our the data scientist or even our data engineers to work every time to do the repetitive jobs which they have been doing through the years. Okay, so that is what we want to avoid doing that. That is where our DevOps methodology comes handy for implementation of any of the ML related model implementation. Okay, so all data conditioning, ETL or ELD processes, those all things can be taken care with the help of the DevOps implementation. Okay, so again, I will pause here for a while so that you can go through those requirements as well as the challenges which we face for ML. Okay, so now let's move on for how DevOps helps machine learning. So first of all, we have to convert that whatever we have seen from the block diagram aspect or the functional aspect to the actual services. So this is how it looks like. From the data per se, you will have n number of services depending upon the data type you are interacting with. Similarly, if you the way I was saying for data transformation, you will have a data factory or respective all data breaks or SD inside, which actually does the work or heavy lifting from the modern data warehouse, right? Conversion of the data in a desired format. Now at heart of this is your machine learning, right? So depending upon whether you are a data scientist, whether you are a developer or a implementer who actually does the work of making this model available on your platform. So this is what the users you will look through, and the services from where we can fetch our data or use, I would say, ML powered apps we say. Okay, so it is like Azure App Services, Azure Functions, and IoT equipment. Okay, so these are some of the services which are kind of a data handler, I would say, from where we get the data. And at times we also in case of while we output our in form of dashboard or Power BI, we output them in the form of the website or something which is available publicly. Okay, so this is what is our consumption layer as well as an output layer where we actually provide our data or machine learning output. Okay, now container deployment, why we have this and what's the use of this. Now ideally our work can be done with normal app services, functions, and RTH, but for us to leverage the microservice approach or even the complexity of handling those each and every modular things, so that they can scale through independently and they talk over the API layer. Okay, this is important. Container instance and Kubernetes services, because this is the layer where actually you will see each and every module working isolated and they can scale out on their own. The only connection with them is using APIs. That means all are modular. The upgrades and everything can be taken care at the respective layer. Okay, so this is where you have two options. One, go through the basic application services like app services, or you do the container deployment if you want to go for the microservices approach. Now, while we are saying DevOps, where the DevOps fit in, DevOps will come handy for all of these service implementation end to end. What we are doing with the help of this is we are doing all infra as a code at first place, managing all configurations, the data at places so that we can go through them. Okay. And obviously, as we are working on the machine learning algorithms, okay, so version control and tracking is equally important for the models. And how do we take care of actual artifacts? Okay, so that is where we will look into the build and the release part of that, so that how do we know that the code which we have built or something which, so this, say I would give you a simple example like experiment or that particular script, how do we say that this particular script is now free from errors? So that is where our build will come into picture and it will do the testing on top of that before we can release that to production systems. Okay, and then finally is about the monitoring. So if you see in the ML world, this is what we are doing from an experiment and from the DevOps per se, what we get through. We get through each and every experiments are stored as a code, and we get a history or version of out of that along with the data. Similar is for our compute. They are only spin up when we actually require them with the help of the DevOps. Data set and modeling, again, all the modern data warehouse or data factory equipments or components which you have gone through for the transformation, implemented using the DevOps at the runtime or being triggered at the runtime using that particular triggers. So that is where the DevOps is quite handy in implementing them. And finally, as we already been talking about the workflows or model management, so that is where your pipelines, event-driven and end-to-end is making all those workflow come live. Okay, and finally, monitoring and drift is just the monitoring of whether we are really following up with that. So if I have to further double click on each of components and what you will deploy as a part of DevOps end to end, this is what your machine learning for DevOps will look like. And this is applicable for almost all of the service or use cases. The things which will change is only the few bits and pieces from an configuration aspects. Okay, so say suppose if I have to start, let me first of all increase the size. Yeah. So say suppose first of all, let me think about I only have those respective scripts or experiments available with me, and I just have a data, know from where to pull the data from. Okay, so at first layer, I have to make this model created. Okay, so if you see this particular pipeline from DevOps, which is nothing but the Azure pipeline, we call this a build pipeline. So what we want to do as part of this is create first of all a machine learning workspace and make sure we have the available compute. That means machines, whether it is a single machine or a cluster, is available to us. And then from the code perspective, that means whatever the experiment or the scripts which we have along with the data. Okay, how do we do the sanity check, whether that is available in the shape and format required, or if we want to make them available as a package, how do we package them in and use them as an artifacts? So these all things are taken care at this pipeline, which is called the build pipeline. Now, from this layer of build, we actually start training our model. That means now we have a required resources available for machine learning. We know from where to fetch the data, and we know what application or what program or model we are going to use. Okay, or what particular use case we are trying to use. Now, based on that, we are actually going to train or make sure this accuracy and evaluation fits that particular use case. So we have to use the data artifacts within this machine learning pipeline, okay, which is actually inside this particular workspace. Okay, so this goes through this particular model, goes in a training, evaluation, and register. That means first of all, at this point of time, it's just evaluating what on which particular parameters it has to train itself through, or then finally evaluate with the data output what exactly whether it is really following up with that particular use case. Okay, that means output is equivalent or lies within that range which we are actually monitoring for. Okay, and finally we know that this works fine from machine learning aspect. We registered this model with the help of model AML model management. Okay, this again is a part of our machine learning workspace. So remember, whatever I am showing you here is a part of Azure machine learning workspace, which I'm just going to cover from the tools aspect in a minute. Okay, but from a DevOps aspect, just understand what kind of the work we will do from the DevOps, which will do end-to-end heavy lifting of this implementation. Okay, so you register this model. Okay, then now with the help of this model, this is now reusable model for us. Now for me to reuse that for any other customer from a similar industry, what I want to do is just package the model into image or make that available as an artifact. So this is a kind of a staging or QA environment. Okay, so initially while we try to test it for kind of a pre-production environment or staging or QA environment, we deploy this as a container instance. As I said, for us to save or run it only for that particular time, we have to think about the approach as well as think about the microservice or modularity approach for a specific service. So that is the reason we are using the container instance as well as the Kubernetes. So for staging pre-prod, we are using container instance, and for production, similar model is also deployed to production once we are through approvals that yes, this is going to work as it is for. So we will deploy them in a AKS cluster, because here it will be a scale, right? It will be done for a complete industry use case. Like example, I can give you from the health industry, right? So n number of uh, uh, patients will be there, and they are being diagnosed for the critical illness they have against someone having the similar kind of history in the past. So you can think about the prediction of those models, how important they are for our industry use cases. Okay, similarly the output which we get based upon the parameters we fetch through this machine learning are quite critical from that particular industry use case. Okay, so first, complexity. Other thing is how do we do the sanity checks on the data and the code. Third one is actual flow of the model. That means how you register this model and make them available as a reusable component here. Okay, and last, which the component which we always do is from the data drift and the monitoring aspect is written here from the app inside, which is nothing but it will either have that stored as a historical and provide us levers in terms of the dashboard that what is going in line or where it needs to be changed. Okay, so these all things will be taken care while we do the deep dive for ML, or I would say the implementation of these models while we meet next week on the deployment part of this ML. Okay, remember whatever the concept which we have gone through from the deep learning or from the machine learning aspects, the models will remain same, technology will remain same. There is nothing out of this particular concept. The terminologies will be same. Only thing which you have to work is on the hands-on is to understand each of these thoroughly is what is required. So once you get them, I think you are through with this machine learning aspect of this. Okay, now coming to the native tools. Okay, so what are these native tools? So while I log on, or while you create it through using build or whatever that pipeline using automation, you will have a similar kind of the studio with you. So this here you will manage your compute data experiments. You will see all of these as a dashboard. Okay, and you will also have the important two aspects out of this is this is a single unified view. Okay, irrespective of whatever you are being using from the whether it is the data modeling or what kind of the scripts you are running, the data sets you are fetching through, the important aspects for you to note here is AutoML designer, and then something to look on the models. Okay, the other parts, compute, data store, and these all are the integral part, which is implemented part of your infra as a code while we implemented this. Okay, so I can show you while I go through on the actual implementation of this. Okay, also show you how this will look like on the Azure. So therefore we move further on understanding this, as I said, two aspects. AutoML, what that is being used for is we have to understand. Similarly, what the designer is for, we have to understand. See, AutoML, as the way it says, if you have the data at your hand and you are sure about what exactly the parameters you are looking out of that. That means if it is a insurance use case or it is a healthcare use case, you are already aware of what diagnostics you are doing on top of that. So based on that, it gives you the classification or prediction, or I would say a time-based model for that particular use case. So that is where you will use an automated machine learning, which based on your performance criteria detects which is the best model to fit for, or I would say based on the data you will push into this particular machine learning workspace, it gives you what best fits your data by going through that. That is what is an automated machine learning for. Other thing is, okay, I know this, but what if I have to my data is not in a usable form and I want to really run some customized data transformation. So for that, I think we have to move to the machine kind of a workflow. Okay, so that workflow is nothing but the machine learning designer. Okay, so this is how that will look like. Now here they have shown for something diabetes data set, that is a healthcare industry use case, but it can be anything from an insurance industry as well for the sales of the that insurance for that particular vehicle. Similarly, it can be anything on IoT as well. Purely based upon what model you select, this the flow chart is nothing but the workflow, which in itself is used by people who are just or not having a good coding experience. They can just drag and drop the relevant models, or I would say the task in the pipeline to get the desired result. So how it is helping? First of all, you don't need any coding experience here. Second thing, you just know about that you want to do the transformation of your data in and out. Okay, so transform, make it useful for that particular use case, and then accordingly get the output based upon the model you selected. So here machine learning design, again, see there are two pipelines. One is one thing which we saw from the data DevOps per se was Azure build pipeline. That is from the implementation per se. Similarly is for the release pipeline. That is also from implementation per se. Now this pipelines which you are seeing from machine learning, they are specific to AI pipelines, which are workflows within the machine learning workspace. So what I have shown you here, they run under this. Okay, so these pipelines which you see are within this particular machine learning workspace. Okay, so just to clear out if there is any confusion on what pipeline we are talking about, and till the time we are going through these pipelines, okay, we call this as a the data or training pipeline. Okay, till the time we actually come out with the model and make them available for reusability. So this is called the training and learning pipelines. So because on top of that, you will also have a scoring and evaluation built. That means how do I make sure that this algorithm or whatever the model I trained for so and so data is accurate. Okay, so that is where the data preparation, scoring and evaluation, these all things will come into picture. Now, similar to this, there is also called inference pipeline. Inference pipeline is the ready to use, or I would say ready to use model for us. That means similar to what I have been talking about, the deep neural networks or deep learning from TensorFlow or the PyTorch. So they are already built for a specific use case. We just have to use them as a trained model. Okay, so consider this block equivalent to whatever we did as a complete model. They are ready to consume in this. What we just need is how to get data. So here is the data. What is If it is an API, we will get an web service API. If we have to produce an output out of this to any other particular output to any particular website, we will produce that as a web service output. Okay, the here what we have, the complete engine what you are seeing here is our complete inference pipeline or ready to use pipeline, just related to transformation, data connections, and finally providing us a desired output. That's it. So I will just pause here so that you can look into both of them. Okay, first of all, machine learning workspace, single uh, uh, particular tool we use for machine learning. Okay, we have the graphical tools within that, AutoML and Designer. Machine learning, what you see within that is this. You have data set, run on respective, you know what is the output you want and select from the type of whether you want to classify it, whether you want to predict something, or you want based on time series you want to see at particular time or that particular seasonality, what that output should look like, kind of a prediction. So here you know, right, what exactly the output you want, and with the help of AutoML, you just select the best particular task or what best particular transformation you want to apply or use the AI technologies. Designer workflow. OK, so here you want to train that model. That means what I want is for my experiment to be successful, whatever I need. OK, as an components, I'm just fetching them here in the form of UI, and the backend work is already available in these tasks. So it can be a language specific. It can be that is already being available as a drag and drop utility within that designer. Finally, for me to make this, whether this model is accurate or not, I have to give them the evaluation. So that is where if you see after the moment I do the training and do my work, I have the scoring and evaluation part at the top of this. So with this particular task, I'm sure that this model is now ready to go for a specific use case. And then I use the inference pipeline, which is similar to that, but this is used by anyone who wants to utilize the same model, same art, same thing required, the data required in a specific shape and form, which is taken care with the help of this transformation and providing output based on whether you are putting it on a dashboard or you are consuming internally with help of reports, purely depends upon you. OK, so Tim, that's all for our concept. One more thing I want to show you is how it looks like in Azure. So suppose I have just created this one particular deployment, and this is how it will look like. You will have machine learning service being created, application insights, you have key vault, container registry, and storage account. And how this look inside the designer is how these, as I said, like designer gives you out of box some models for ready to consume as a drag and drop or UI is this. Image classification, binary classification, these are all the algorithms which you have talked through. So as you get some time, I think you can look into each and every models. OK, and also while we do the hands-on lab, we can talk more about, or I would say double click on each of them to see what we get out of these. OK, similarly, AutoML, as I shown you, you can just while you are trying out with some data, you can just go through this particular data set and try the configuration run, select the task. I think while you create that that particular task or data set, and just go ahead and give them some experiment name. OK, some dummy name, search for what exactly you required for that particular like here it is diabetic, so obviously the BP and all the medical parameters will come here. Compute cluster, if you are running any compute cluster or instance, that will you have to select. Similar is for your this. Say suppose even if I give some, say suppose at this point of time, say let's go with the some dummy names. Okay, say I want to go for this text, and if I select next on top of that, see it gives me the based on the data which I provided, I should go for the regression to predict the numeric values because I'm going for the diabetic, whether that patient is diabetic or not. Okay, so this classification and negation, all these will look from the similar aspects. And similarly, while out of the auto learning, you can also look into the go back to the designer part. Okay, so if you want to try the designer part, you can look into the all samples available for you to try it out. And these are the, as I said, these are already the available to you out of box. The flow is already being done. You just have to look into how you connect the input and how where you exactly want to pass out your data. So you can use this, or you can use the workflows, or I would say components out of box. So that's all as a part of this concept session.